Okay, now we have a statistician that's designing a study. They're going to use the results to construct a 99% confidence interval, and what we're trying to find here is the minimum sample size that should be used. So we have our confidence level of 99%. We want our margin of error that we want is $15, and we have an estimate for the standard deviation of $125. And all of those things go into the formula for the minimum sample size. Okay, so here's what our formula looks like. So we've got the z of alpha over 2 squared and the sigma squared. The sigma is going to be our estimate of the standard deviation. And then the e squared on the bottom, the e is the margin of error that we want. Now for a 99% confidence level, that means that we're going to take alpha and divide by 2. The alpha would be 0.01. If we divide that by 2, we've got 0.005. So for our critical value, one thing we can do is look up 0.0050 in the middle of our table, and there's a table down here at the bottom. So we're trying to find the closest thing to 0.0050, and it's actually halfway between the 0.0051 and the 0.0049. So we could use 2.575. And this is negative right here, but remember for critical values we're going to use the positive value. So we can use 2.575 for our critical value, and that means that we're putting in 2.575 here. In place of the sigma, we're using 125, and then in place of the e, we're using 15. And that gives us 460.5. Remember, for minimum sample sizes, we're always going to round up, so this should be 461. Okay, question number 4. In this one, we're trying to find the margin of error for a confidence interval. And remember, anytime that it says average, like right here, that's the same as a mean. So we have a sample mean of 649, and remember that's going to be our point estimate. Our sample size is 680, and our sample standard deviation, the S, is 180. And down here we've got our confidence level of 95%. Since we're dealing with a confidence interval that has to do with a mean, that means that the formula we want to use for the margin of error is t of alpha over 2 times s over the square root of n. For the critical value t of alpha over 2, we have to use the t distribution. The s will be our sample standard deviation of $180, and the n is the 680, the sample size. For our critical value, our alpha, since we're looking at 95% confidence, our alpha is going to be 0.05. We want to look that up in our t table under the area and two tails, under the 0.05. Now since our n is 680, we don't have that exact value in our table. We don't have 679, which would be our degrees of freedom. So we're just going to use the closest one, which is the 750. Our critical value here would be the 1.963. So we have that, and with our formula up here, we can put in 1.963, and our S is 180, and our N is 680. And that's going to give us 13.5 for our margin of error. Now in the problem it says to round to the nearest dollar, so we're going to round this to 14. Okay, question number 5. We have a simple random sample of 400 individuals, and out of those 400, 140 answered yes to a question. So we're trying to find the point estimate for the proportion of the population that would provide yes responses. Well, the point estimate is just our sample proportion. So really all we need to do here is divide the 140 by 400 to get our proportion there, and that's going to come out to be 0.35. So again, this was just the 140 divided by the 400. Okay, and number 6, we want to have a 95% confidence interval with a margin of error of 2 percentage points. And since we're talking about percentage points here, that means that we're looking at a confidence interval for a proportion. So we want to find the minimum sample size that should be used. So our critical value for this one, our alpha would be 0.05. We're going to have to divide that by 2. And then we're going to look up the 0.0250 in the middle of our z-scores table. And actually here it has that exact value. So that would go with a z-score of negative 1.96. And since we're talking about a critical value, we're just going to take that negative off. And for the margin of error that we want, remember we have to put this in decimal form instead of percentage form. So whereas it says 2 percentage points, we're going to use 0.02. And now remember, in the case where there's no prior estimate for the proportion for the P, then in our formula we have a 0.25. So here's what the formula looks like. We have n equals z of alpha over 2 squared times 0.25 divided by e squared. So in place of the z of alpha over 2 right here, we're going to put in 1.96. In place of the e, we put in 0.02, and that gives us a value of 2,401. And it comes out to be exactly that, so we don't have to do any rounding at all. So in this one, we've got 651 sales managers, so that's our sample size. And for the first question, we're looking for a confidence interval estimate for the percentage of managers that say being a sloppy dresser can make a sales representative's jobs more difficult. So for the first question, we're looking at this 94% being our point estimate. And again, we're going to convert that to a decimal form. Now this time we're constructing a 90% confidence interval. That means our alpha is 0.1, alpha over 2 is 0.05. And since we're estimating a proportion, then again we're going to use the z table. So we're going to look up 0.0500 in the middle of our z-scores table. And it's actually halfway between negative 1.64 and negative 1.65. So we can use negative 1.645. And remember, we're just going to take that negative off. Okay, so here's our formula for our margin of error. We've got our critical value here. Then underneath our radical, we've got p hat, which is the 0.94. The q hat is 0.06. And the n is 651. We get 0.015. We're rounding this to 3 decimal places. That's our margin of error. Now we actually have to construct our confidence interval. So we're going to use our point estimate, which was the 0.94. So we're going to take that and subtract our margin of error to get our lower limit. That gives us 0.925. We take our point estimate and add the margin of error. We get 0.955. Now we would do the same thing in part B, only here we're going to use 75% for our point estimate and for our p hat. We're still constructing a 90% confidence interval, so the critical value will be the same. So in this one we would have, instead of 0.94, we would have 0.75, and then we would have 0.25 for our q hat. We still have 651 for our sample size, and this gives us a margin of error of 0.028. Our point estimate here will be the 0.75. So if we take the 0.75 minus the 0.028, it's going to give us 0.722. The 0.75 plus the 0.028 is 0.778. So in this problem, we already have the confidence interval limits, and we're trying to use those to find the point estimate, which remember is right in the middle of the confidence interval, and then the margin of error. So to find the point estimate, or the sample proportion, we're just finding the average of the 2 confidence interval limits. We're taking the 2 numbers, adding them together, and dividing by 2. And that's going to give us 0.43. Now to find the margin of error, all we need to know is how far it is from that sample proportion, which is in the middle of the confidence interval, to either one of our 2 limits. So for example, if we took the 0.430 and subtracted the lower confidence interval limit of 0.405, that would tell us what the margin of error is, and that gives us 0.025. So we have our sample proportion, which is 0.430, and our margin of error, which is 0.025. Okay, for number 14, we're finding a critical value that corresponds to a degree of confidence of 96%. And this is a z value, so we're going to use our z-scores table. Remember, we have to find alpha. So our alpha for this one, we would take 100% minus the 96%, that gives us 4%, and then we change that to a decimal form. So that's going to be 0.04. Then we want to divide that by 2, which gives us 0.02. So we would want to look up 0.0200 in our z-scores table. Remember, pay a lot of attention to where your decimal point is, because it's easy to get these mixed up. So if we're looking for 0.0200, the closest 2 on either side of that are 0.0202 and 0.0197. And actually the 0.0202 is closer, so we would use that z-score for our critical value, which is 2.05. Okay, next problem, we're trying to find the margin of error for a 95% confidence interval to estimate a population mean. We have the sample mean and the sample standard deviation and the sample size. Here's what our formula looks like. We need the t of alpha over 2, our critical value, and we need s, which is the sample standard deviation, and our sample size, n. So we've got our sample standard deviation of 35.0, and the sample size is 36. We could put both of those in there. Then the only other thing we need is the t. So we're looking for a 95% confidence interval, which means our alpha is 0.05. And for the t-table, we need degrees of freedom, which is n minus 1. So we've got 36 minus 1 here, which is 35. So if we look in our t-table at the bottom of the page, and remember for a confidence interval, we want to look under area in two tails. So we're looking in the 0.05 column, the one right in the middle, and we want to use 35 degrees of freedom. Now the problem here is that we've got a 34 and a 36, so we have to decide which one to use. And if you ever have a question like this, you actually want to use the smaller critical value. So we would use the 2.032 here. Okay, so we have 2.032 for t, 35.0 for our sample standard deviation, and then our sample size is 36, and that gives us a margin of error of 11.8. Okay, next question. We've got 301 scores from last year's ACT tests. The sample mean of the test scores was 19.85, and the sample standard deviation was 4.80, and we're constructing a 90% confidence interval for the mean test score. Okay, so here's what our formula looks like. We need to use the t-table. Our degrees of freedom would be 300, and the alpha is going to be 0.10. If we go down to our t-table down here, we've got 300, and remember we're looking under area in two tails. So here's the 0.10 is the second column from the right. That gives us a critical value of 1.65. So that means we can go back and put in 1.65 for the t. Our sample standard deviation was 4.8, and n was 301. And that gives us a margin of error of 0.4565. Now our point estimate is the sample mean test score, which was the 19.85. So now we want to take 19.85 minus our margin of error. We're just going to round that margin of error to 2 decimal places now, so 0.46, which gives us 19.39. And if we add the margin of error, we get 20.31. Number 20, we have a survey of 2,225 community college students. 1,157 of them were under the age of 23. And here we're just trying to find a point estimate for the population proportion. Remember, a point estimate is just a sample statistic. So in this case, all we want to do is find the proportion that we get for the number that were under 23. So we're going to divide the 1157 by the 2,225, and we're going to put that in decimal form. That actually comes out to be 0.52. Okay, next question. Okay, the minimum sample size that we need to construct a 95% confidence interval if we want a margin of error of 5 percentage points and a planning value, which means a value that we already can guess for p of 0.30. Okay, so here's the formula that we're going to use for this one. Since we do have an estimate for p, or p hat, the z is going to be our critical value, so we need to find a critical value for an alpha of 0.01. So we're dividing the alpha by 2. Then we're going to look up that value in our z-scores table. So 0.005. Again, this is exactly halfway between two values, so we would use 2.575. So we're going to put 2.575 in there. And for our P and our Q, we're going to use the estimates that we've got. For P, we're going to use 0.30. And for Q, it's going to be 1 minus P, so that would be 0.70. And the margin of error, remember everything in this problem that's a proportion has to be in decimal form. So when it says the margin of error needs to be 5 percentage points, we're going to write that as 0.05. And that is especially important in this problem in order to get the correct answer, that you do put everything in decimal form. So if we plug all that into our calculator, we get 556.97. We're always going to round up to the next highest whole number when we're doing sample sizes. And in this one, depending on whether you used your calculator or the table to get the critical value, you could get just a little bit of rounding error. So the one that's the closest to the value we came up to with is the 0.558.